Hey guys, so in this video I'm going to show you how to add the first car to the game and how to make the car move from one side of the screen to the other and to reset the car position to the beginning each time it reaches the end. So we can create this looping movement of the car. So let me show you what the end result will look like, and it's basically this. So we're going to have the car moving from the right side of the screen to the left, and when it reaches the end of the screen, we are going to reset the position of the car back to the beginning, so it looks like it's just we have like a lot of cars passing by. And what I'm actually doing here is that I'm actually changing the position of the car when it reaches the end of the screen. So when it gets out of the screen on the left side, I'm actually just taking the car and setting the position back to the beginning, and it just keeps moving like it was before. So I'm going to show you how to do this. I'm going to stop this. And the first thing I did was to add the car sprite. So in between, I draw all the sprites that I was missing. So I have all the cars, the truck, the lady frog, the fly. I have everything, all the sprites ready, and I designed them all with Pisco. And so the first thing I did was adding the car sprite. So I just created a new actor. I added a single sprite, so we only need a single image because the cars don't have any animation, so we only need a single frame. And but one thing I needed to do was to adjust the collision of the car. And this is because when we import the sprites, when we import the frames or the animations, whatever you want to call it, the images, the collision the collision bounds of the image will get the entire size of the image. So in this case, the collision bounds of both the car and the frog would had like 32 by 32 pixels. And what was happening was that when the car was passing by the frog and the frog was still on the initial lane, like on the let me show you. Okay, when the frog was here and the car just passed by on the first line, the car was touching the frog and just pushing the frog along the way. So what I ended up doing was reducing the size of the collision bounds of the car and also of the frog. And probably I'm going to do this in all the frames because it doesn't really make a difference. I'm just cutting like 1 pixel from each side. So you can see here we have the size of the image, this gray line all around, and this is the collision bounds. And what I ended up doing was reducing the size to 30 pixels by 30 and just positioning on the X and the Y by one pixel of offset on the X and Y. So it is centered. And I did this both for the car and also for the frog. And probably, like I said, I'm going to be doing this for probably most of the sprites. So instead of having the entire size, it's going to be like a little bit smaller. And I think it's not going to mess up with the collisions in the game because since we are moving on a grid, it doesn't make any difference to have the collision like this. So I don't think that's a problem, and it solved the problem that they were intersecting despite being on different rows on the grid. So this was the first thing that I did. The second one was you can see that I no longer have the frog on the initial lane, and this was because I decided that I don't want the actors to be already on the scene, so I'm going to have a game manager that is going to be responsible for the game logic and for creating all the entities that we need in our game. And this is because eventually when the frog dies, we are going to need to reset the frog to the starting position and probably reset the cards and all the other entities. So we need to have one entity to be responsible for creating all the other actors. And in this case, it's the game manager, and the game manager in this game, I added the game manager to the actual scene. So the scene has now a new behavior, which I call game manager, and it's going to be the one where we are going to deal with all the game logic. So I added a new behavior, and now you can see that I have two new actor behaviors, one for the NPCs and one for the player. I'll go into the NPC in just a moment. And I added a new behavior for the scenes that I call game manager. I also changed the names, the naming convention that I'm using for the behaviors, because I realized that behaviors are actually the corresponding to classes in programming languages, at least I think so. That's the way I'm seeing it. So behaviors are classes, and the events inside the behaviors are corresponding to methods or functions that we have inside the classes in the other programming languages. So I ended up using the same naming convention that I use when I'm programming with C#, which is the main language that I use. So classes, in this case the behaviors, are using a camel, not a camel case. Yes, camel case. I think lower camel case or Pascal case. No, camel case. Camel case is you have the first letter of each word on the uppercase and all the other ones are lowercase. So like this, game manager, the first letter of each word is on uppercase. So you can see that I changed all of them to have this naming convention. And then inside the game manager, in this case I only have the created event, but you're going to see that I'm using also the camel convention for the events, which correspond to methods on programming languages. And so, like I was saying, I added a game manager. The game manager is the one that's going to be responsible for implementing the game logic and also for creating the actors. So the first thing that I did was add the event, the created event. So when the game manager is created, when the scene starts, in this case, when the scene is created, because this is applied to the scene, I create both the frog and the first, the car that we just added. So you can see that I got these blocks from here, from the scenes category. You can see that we have create actor blocks. So we can create an actor at a specific position on the X and the Y. And we can also create an actor on a specific position and also change the layer. I didn't felt the need to change the layer, so I just used the other one. I just created the actor on the X and Y position. So in this case, I created the frog on the initial position that we wanted. So 208 and 448. Let me just open Figma just to make sure, yeah, frog, that this is the correct position. Yeah, okay, so this is the one, 208, 448. And in case of the car, so the car is going to start on the next row in our grid, and it's going to start outside of the game. So we don't see the car, at least for now. Then we are going to change this, but at least for now, that's how we are going to implement it. So I'm just instantiating the car outside of the screen on the right side and on this row. So this row has the y is equal to 416 and x is equal to 448. And why 448? Because our screen has a width of 448, and since the image has a top left corner, I mean the position of the image, the origin of the image is on the top left corner, so when we position it on the 448 on the X, it means that it starts already outside of the screen. And so the game manager now is the one responsible for creating the frog and creating the first card. So when the game starts, the game managers create both actors, and then each actor has its own behaviors that deals with their own abilities. So in this case, the frog has the player movement behavior, which is the one that we can use to move the frog around with our input, with the arrow keys. And I created a new behavior for the car, which I called NPC behavior, NPC from non-playable character. And this behavior is just responsible for making the car moving from the right to the left with a constant speed. And this is one of the cases where using the behaviors is really an advantage, because I created just an NPC movement, and you can see that I didn't call it car movement. And this is because I'm thinking of using this behavior to basically everything that moves on the screen. So we have the cars, we have the logs, we have the turtles. All these have the same behavior. They all start from one side of the screen, either right or left, and they all move at a constant speed from one side to the other, and they reset their position. So I'm going to end up using this behavior on all of these entities. So this is a really good feature of Stencyl, that we can reuse the behaviors on different actors. So what does this behavior do, the NPC movement behavior does? So I added a created event. So when the car, in this case, is created, what I do is, I'm not going to worry about this at the moment. So initially, I'm gonna go block by block. So this was the main one. So basically what we need to do is just set the x speed, so the speed on the horizontal axis, to a certain value. And you can see that I created an attribute for the value, so I didn't input the value directly here. I could if I wanted, but I chose to set an attribute. And this is because since I'm thinking of reusing this behavior with other actors, and the actors are going to have different speeds. So we have five different types of cars, and each lane of traffic has a different speed. So I created an attribute. You can see here on the attributes. Let me show you. So I created a new attribute called speed, and I selected this attribute as not hidden, so it's a public attribute, so that we can change the value of the attribute outside of the behavior. This is really good because having this speed attribute as a public variable or a public attribute, I can change and give in the specific and different values to each actor that I'm applying this behavior to. So I can set the speed like -5 to the car 1, then I can set another speed value to a different car. That's why I'm using a public attribute. And in this case, this is not the correct speed. This is just to show you guys the initial state of the game. The correct speed is -1.8, and I got to this value because I didn't find any information on the actual speed of the cars in the original game, so I just watched some videos of the Frogger and timed the cars and saw how much time it took them to go from one side to the other. And this first car takes about 25 seconds to cross the entire screen. So 25 seconds, then we have our screen has 448 pixels. 448 pixels. I divided 448 by 25. It got me to 18 or 17.8, something like that. And according to the documentation, the speed, so the block of the speed, this block, the x speed, represents 10 pixels per second. So the value that you are going to put here, if I set the speed to 1, it means that the actor is going to move at 10 pixels per second. So if I got 18, I divided by 10 and I have -1.8. Why minus? Because the car is moving to the left, from right to the left. So remember that the origin is on the left side. The origin of the scene is on the left, the top left corner. So the position on the left is 0 and the position on the right is 448. If you want the actor to move from right to the left, we need to decrease or give it a negative value, a negative speed value. That's how I got to the -1.8. So this block basically sets the speed, and as soon as we set the speed for the actor just keeps moving with that speed along the screen. And then I had to add a new, some other blocks. And this first block, it got me a while to get to this block because I was having the problem. Like I told you, like I want to when the actor reached the end of the screen, I wanted to reset the position of the actor back to the beginning. And what was happening, and what happens by default, is that when the actor reaches the end of the screen, gets out of the screen, the stencil by default disables the actor, so anything else runs on that actor. So I was not being able to trigger the event that when the actor reached the end of the screen. So, and turns out the way to solve it is to add this block, make self active always. And what this does is that the behaviors on this actor are going to run either if it's on the screen or not. So the actor is not disabled automatically when it gets off the screen. So remember that when we are using actors that we want to trigger something or do something with it, when they are out of the screen, we need to make them active always. So I added this other block, and then I created a new block to save the initial position. And why is that? Because like I told you, I want the car to, when the car reaches the end of the screen, I want to position the car back to the beginning. And since we are going to be using this behavior on different cars, each one of the cars or each one of the actors that are going to be using actually, now that I'm think about it, No, I made a mistake here. Now I was explaining to you guys, but no, 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 this is not correct. I don't need to save the initial position because the actors only change the Y position. And the Y position, we are not changing the Y position. Oh, yeah, I just made a mistake here. So we actually don't need to set the initial position, or do we? No, we need. Sorry, I just added this before starting to recording. Like I shouldn't be doing changes to what I implemented right before starting to record. But now that I'm thinking, okay, I'm thinking that maybe we didn't need to use we didn't need to save the X position because the actors only change in the Y. But then again, each actor doesn't know the initial position that it started. But we know, sorry, I'm thinking out loud right now, just like debugging in process, but we know that all the actors are going to start at the same position. They are always going to start at the outside of the screen on the right side, which is always 448, which is the width of the screen. So yes, we don't need an attribute. But basically what I did, just to explain to you guys when I thought this was the right way, is that I created an attribute to save the original position in a way that when the car reached the end of the screen, I could just set this is position to this value that I saved before. But we actually don't need this. So I'm gonna remove this and remove the initial position. We don't need it. How can I remove it? Oh, it's here. Okay, so we don't need to save the initial position because we can just add it here by hand with a static value. It's always 448. It doesn't depend on the actor that this behavior is assigned to. So this was a mistake. And before I'm setting the value, let me just show you. So I added an event to detect when the actor got out of the screen. I added a new event from the actors, from the actors category, and you have like enters or leave the scene or screen. And I showed a specific actor, and basically this event is triggered when a self, so the actor that it is applied to, exits the screen. And basically this event triggers when each actor just gets out of the screen. But remember, this event only works when we add the make self active always, because otherwise it won't work. It got me a while to get to that block. So basically what I'm doing is that when the actor gets out of the screen, I set the X position back to 448. And once again, sorry for the mistake, but actually we don't need the initial position. We know that all the actors are going to start from 448, which is on the right side of the screen. Yes. Not the ones that are on the left, but we'll change this in just a bit. So we'll just stick with this at this moment. Let me just test to see if it's working properly. And I think this is where like the main changes that I did. Okay, so now we have the car moving and it takes a lot of time moving. Oh, and this is also that something really weird that I need to check, but it doesn't affect the game. But you can see that the car can now push the frog, but which is okay. But if I take the frog from in the outside of the front of the car, it just keeps moving. I don't know why. But it doesn't matter because as soon as the frog touches the car, it loses a life and we reset the position of the frog. So it doesn't matter for our game. And you can see the car just crossed the screen, started back from the beginning, and it keeps moving. And I just remembered that I did also some other changes, but I think they are not really important. So on the car, you go to the physics category, then you have a lot of properties and options about the physics. So initially, the frog was able to push the car, so the car was moving, and when I moved the frog and touched the car, it was pushing the car. And so I chose to cannot be pushed because that's what's going to happen. So we want the frog to just touch the car and the car just keeps moving. So the frog cannot push the car and the frog will die. So cannot be pushed, cannot rotate because this was also happening. The frog was pushing the car and just changing the rotation of the car. So we also don't want that to happen. And I changed something else here. No, nothing else. But I think this is not very important. This was why when I was trying to understand the collision between the car and the frog, because that was happening because of collision bounds, and I was like messing around with these options to see if I could fix it. This is it. I mean, at least for now, we are going to change some of this code later, but for now, this is it. Adding the first car and making the first car move from one side of the screen to the other one, and resetting the position at the end. So this is it. I'll see you on the next video. Thanks.